Hi, my name is David Jones. I'm the Forestry Non-Point Source Senior Specialist for the North Carolina Forest Service. I'm currently pursuing a Master of GIS at North Carolina State University. For a class final project, I looked at identifying forest harvest sites using remote sensing and GIS. I'd like to cover that topic in 5 minutes or less. For the class final project, the primary research question was, can active and recently closed forest harvest sites be identified using a relatively simple methodology, publicly available satellite imagery, and other collateral GIS datasets? The reason I asked this question was because forest harvesting occurs across the landscape, making on-the-ground identification methods very time-consuming and costly, and because a remote sensing and GIS-based methodology could help state forestry agencies identify harvest sites where forestry best management practices monitoring can be conducted, which would improve project efficiency and reduce project costs. Initially, I looked at using several different spatial data and literature sources, but in the end, I only used 2 spatial data sets and 1 literature source. The spatial data were Landsat 7 satellite imagery and National Land Cover Database 2006 dataset. The literature source was a master's thesis written by S. Chambers from Virginia Tech. This is a flow diagram illustrating the process that I went through. I downloaded, unzipped, and organized spatial data, clipped NLCD to North Carolina boundary, and reprojected some data as needed. I then tested various methods in ERDAS Imagine and ESRI ArcGIS software and evaluated these products over orthophotography. Ultimately, the Band 7 temporal change method seemed to stand out from the rest. So that is the process that I used. In my final analysis, I extracted Landsat Band 7 values greater than 0 so that I could remove the scanline error areas. I then extracted NLCD forest classes. In the raster analysis, I did a very simple subtraction of Band 7 datasets, subtracting October 2012 from November 2012. Looking at that over photography, I identified values greater than or equal to 20 as ones that identified forest removal the best. I then extracted those values to a new dataset. I added the extracted Band 7 product to the NLCD forest classes, and the final result was a forested landscapes with notable vegetation change or vegetation removal. I supplemented this analysis by conducting a region group and calculating acres on individual clusters and screened out very small areas that were 1 to 3 pixels in size. This is a flow diagram of the various imagery source products and those products derived from the analysis. The October source product, source image, the November source image, these 2 images without the scanline values. October subtracted from November with the red areas highlighting the greater than or equal to 20 values. This product is the greater than or equal to 20 extracted from the dataset. I then combined with the NLCD forest class yielding forested landscapes with vegetative change from October to November 2012. I then conducted a field verification on the areas identified with the satellite change analysis. Those areas are marked in red here, roughly digitized in yellow, with the yellow areas corresponding to a photograph taken on the ground. All of the areas identified or evaluated in the field identified by the satellite change detection process were of vegetative removal. Some of those areas were not associated with forestry activities, but associated with conversion to agriculture or urban landscapes. In conclusion, active and recently closed harvest sites can be identified using relatively simple satellite imagery analysis in combination with collateral GIS data. In my case, Landsat 7 Band 7 temporal change yielded the best results. It highlighted vegetation moisture change in particular. More complex imagery analysis techniques yielded mixed results in my analysis and were also more time, labor, and hardware intensive. Some opportunities exist to incorporate other data down the road. The Landsat Data Continuity Mission will hopefully provide satellite imagery in the early 2013 without scanline errors. And there are ways to filter out areas of forest removal that are not associated with forestry, which would be through the addition of other collateral data. If you'd like a write-up of the technical procedures used, please feel free to contact me. Thank you for your time.